Coordinate proofs, of course I got it working. Why would you ever doubt me?
Because you can't draw.
Coordinate proofs. Okay, some things that we need to review, and this was in the assignment from yesterday, so I'm going to kind of review that with you now. If you didn't know how to do them yesterday, don't worry about it. That assignment was just meant to kind of get you thinking about the direction we're heading in, so don't panic about that assignment. Slope. How do you find slope between 2 points? Bryce.
xy minus x y1.
Okay.
And then x2 minus y2.
Okay. Almost. Anyone want to correct him? Travis.
y2 minus y1 over x2 minus
y2.
There you go. Yep. The y's go on top. Shh. So it's y2.
Miss Strigno.
Yep.
I need a pencil
Why did you wait until now to ask me that?
because I forgot mine broke.
Okay. Okay. There's your formula for slope. Okay. And so you're always subtracting the two y values and subtracting the two x values, and the y values need to go on top. Travis.
For me, it's easier to do add a line, change the sign.
Oh.
Do that.
Yeah, when you're subtracting, yeah, you absolutely can do that. Sure. Okay. What do you know about parallel lines when it comes to slopes? Kyle. Okay, they are straight.
Exactly the same.
The slope is the same, yes. So parallel lines have equal slopes. That's going to be important.
They never cross.
Okay, the lines themselves never cross, but the important thing to know about slope is that the slopes are exactly equal if the lines are parallel. Okay, so if I gave you two lines and I said, show me that these are parallel, you could do it by showing me that their slopes were the same. What about the slopes of perpendicular lines? Do you remember?
One's negative, one's positive.
Okay, they are opposite. There's another word to throw in there. Opposite.
Attract.
Integers?
Nope. So if it was positive, you make it negative. That's opposite. What else do you do to it? You flip it, which is called the reciprocal.
Opposite reciprocal. So reciprocal is the opposite. The opposite of opposite.
Okay. Not quite.
No sense.
The reciprocal in math, that's not what reciprocal means. Okay, in math, opposite means positive, negative. Okay, reciprocal means flip the fraction over. So that's why we say opposite reciprocal. Now, I'm going to get a little more technical on you. Okay, this is how you have known to do it forever, the opposite reciprocal. But the actual definition of perpendicular lines are lines where the slopes have a product of 1. Okay, so if the lines have a product of 1, if the slopes have a product of 1, they're perpendicular. What does product mean? Oh, and actually I messed that up. It's negative 1. Oops, negative 1. Product of negative 1. Okay. What does product mean? Nope. Multiplying. Okay, so let me show you an example of why these two are really the same thing. Let's say I have a line with a slope of 2/3, and you wanted to make it perpendicular. If you're thinking opposite reciprocal, what would you do? Negative 3 over 2, yep. When I multiply fractions, I multiply straight across. So if I were to multiply these together, I would get 2 times negative 3 is negative 6. 3 times 2 is positive 6. And negative 6 over 6 is equal to negative 1. So that's why the opposite reciprocal works.
Should we do this?
Okay, I would.
This is for perpendicular lines.
This is for perpendicular lines, yep. Okay. So this is why opposite reciprocal works, is because when you multiply something by the opposite reciprocal, it gives you a product of negative 1. Okay. That's going to be important to know because there's going to be some of these things where we use like variables instead of numbers, and then it's not as easy to catch like the opposite reciprocal thing. Okay? I'm not watching the time. Is one of you guys watching it? Okay. I would love for you to get through the next example if you can, but okay. Okay, consider quadrilateral ABCD below. Prove that this quadrilateral is a parallelogram. My picture up here is probably better than yours. Okay, hold on just a minute. If it's a parallelogram, what do we know about the sides? Okay, they're equal, but they're parallel, right? So what I would really like to do is I would like to show that these sides are parallel and that these sides are parallel. Okay? So let's find the slope of, I'm just going to start up here at the top. Let's find the slope from C to D. Sorry, from D to C, the way I drew that. So I would do 12 minus 12. This is for CD. And when you do this, you are going to want to make sure that you stay organized. Okay, because you're going to have a lot of numbers floating around here. So for CD, I would do 12 minus 12 over x2 minus x1. So that would be 11 minus 3. That comes out to 0 over 8, which is just 0. John?
How do you know which one is x1 and which one is x2?
Oh, that actually doesn't matter. Okay? If you had done this the opposite direction, if you had started with this set of coordinates, that's fine. Just if you start with this y coordinate, make sure you start with this x coordinate. Okay? The only reason we say x2 and x1 is to make sure you go in the same order. Okay? You were going to ask me, why can't I just look at it? Have you ever been able, in a proof, to be able to just look at something and say that it's true?
No.
Thank you. This is a proof.
What's a book on 12?
This is a proof.
Okay.
Thank you. Okay. So now for the bottom one, okay, I would do 0 minus 0. This is for AB. 0 minus 0 over 8 minus 0, which again comes out to 0 over 8, which is 0. Is that right there enough to prove that they're parallel?
Yeah.
Okay, that's enough to prove that those are parallel. How about enough to prove this is a parallelogram? Okay. Yep, we've got to do the other one. So let's do from A to D. Okay, from A to D, I'm doing, this is my coordinate number 2, and this is my coordinate number 1. So I would do 12 minus 0 over 3 minus 0. So that's 12 over 3, which is 4. And then I'm going to go do the other one from B to C. Okay. Which would be, again, 12 minus 0 over 11 minus 8, 12 over 3, which is 4. So what did that tell me? You guys can go ahead and go. But the rest of us, we're not done yet. Isaiah, come on. What did that tell me? What do all those numbers mean? Okay, means that my sides are parallel, right? So then, remember, this is a proof, okay? Again, an easier proof than what you're used to, but it is a proof. So my next step, I would have to say CD, see you later, is parallel to AB, and AD is parallel to BC. And I can say, because the slopes are equal, and if I was trying to prove that this was a parallelogram, what do I want my last statement to be? If my whole goal was to prove that this was a parallelogram. Kyle. Okay, well, I said that my lines are parallel because the slopes are equal. But what if I'm trying to prove that something is a parallelogram? How should my proof end? Kestra?
Therefore, the quadrilateral is a parallel.
Good. Yep. So then I would say quad ABCD is a parallelogram. How do I know that? how does this tell me that this is a parallelogram? Kyle.
Two parallel equal sides.
Okay, so we would call that the what of a parallelogram. Think way back. If that's what a parallelogram is. Definition, good. So this is by definition of parallelogram. I'm not going to fit gram in there. Okay? So you still have to say, after you do the math, you still have to say, okay, here's what that means, and here's what I can conclude. Okay, so that part comes from doing a proof. But this math part, you're probably feeling much better about this than you did about proofs previously, I would hope. Okay? Are we good with that? Do you think you could do something like that on your own? Blank stares, my favorite. Let's try another one. Okay, look at this one. What's different about this one? Okay, it's a different picture. What's different? It's letters, right? Letters this time instead of numbers for the coordinates. Okay, that actually doesn't change anything. Okay, I can still work it the same way. It's just going to be a little more algebra-y. So I'm going to find my slopes. First I'm going to start with PQ. Okay, so from P to Q, I'm going to end up doing B minus B over C minus A. Everyone see where I'm getting that from?
It'll be 0.
Yeah, why is it going to be 0?
Because there's a 0 b.
Okay, because B minus B is equal to 0. And anytime you have a 0 up on the top, the whole fraction is just equal to 0. So that slope is 0. Let's look at R, and what's that other letter? S. From R to S, I'm going to do negative B minus negative B over negative A minus negative C. Doesn't really matter because up on the top, what's negative B minus negative B still going to be?
B.
Nope. 0, right? It's going to be really the same as the top. It's just more complicated with more negatives. But if you have negative B and you're taking away negative B, you would have nothing left. What's that, Kyle? Okay, that would be, let me show you what's really going to happen here. Right, when you have two negatives there, remember two negatives really make a plus. Okay, so negative B plus B, do you agree that that would cancel out and make 0? So this is just equal to 0. I'm going to slide this over and maybe try to get my other work here. Oh, then I can't see my picture. Okay, let's do my other side. So let's do from Q to R. Okay. And so if this is my coordinate number 2 and this is my coordinate number 1, I'm going to do B minus negative B. And Kyle, this might be what you were thinking of. B minus negative B over C minus negative A. What does B minus negative B equal?
2b.
2B, good. Because this really becomes a plus, just like before. That minus and negative becomes a plus. What's the bottom going to say then?
CA.
Not just CA. What's going to go in between them?
C plus A.
C plus A, because those two negatives again make a plus. So that's going to be over C plus A. Okay. And then what's our other one that we haven't done yet? PS. Need to see it. So that's going to be B minus negative B over, what was it, A minus negative C? Is that right? I can't see my picture. Again, B minus negative B is going to become 2B. Okay. A minus negative C is going to become A plus C. So are these two things really the same, this and this?
Yeah.
Yeah, because C plus A on the bottom is the same as A plus C. Okay, so then I can go back to saying that I know PS is parallel to QR and PQ is parallel to SR because slopes are equal. Okay. And then I can say PQRS is a parallelogram. What's my reasoning for that? Good. Definition of parallelogram. Okay. How's that? Crazy hard? I hope not. Okay. Let's talk about relations. Okay. Sometimes it's just going to tell you, draw me a parallelogram. Okay, and prove something about a parallelogram. Or draw me a triangle. Draw me a kite. And if you don't know anything about the coordinates, if they haven't given you specific numbers to put on a coordinate plane.
Pardon the interruption. Please excuse the freshman boys basketball players at this time. We need the freshman boys basketball players dismissed. Thank you.
I swear, that's what the email said. Okay. So these are places that you can put these shapes on the coordinate plane so that you're using the least amount of numbers. Like, for example, if a triangle is isosceles and you put it kind of right in the middle like this, it's going to be the same distance to the right as it is to the left. So you see how they had this as an A and this is a negative A? That means you don't have two different variables you're dealing with. You only have one. Or the right triangle, if you buddy it up right to the middle there, then you've got side lengths that go right along the sides. So these are just good places to put shapes if you are doing a proof totally and 100% on your own. Okay, so you're going to want to be able to refer back to this slide as you're doing some of these proofs. Okay, let's go with our last. Use an indirect proof to show that WO is not perpendicular to line WT. Okay, indirect proof, go back to the very first chapter we did. Okay, maybe it was the second chapter. Do you remember what indirect proof is? Okay, proof by contradiction, does that sound familiar? Okay, remember with indirect proof or proof by contradiction, you assume what? The opposite of what it is you're trying to prove. You assume the opposite and then you show how it wouldn't work. So what are we going to assume?
WT is perpendicular.
Good. Yeah, so we are going to assume, you guys can see the blue, okay. Assume, and it's important to put that sentence in there first, that WO is perpendicular to WT. That's really messy. Okay, so we're going to assume that segment WO is perpendicular to WT. What do we know about perpendicular lines? Kyle? What's that? Okay, we know they intersect. What do you know about them slope-wise? Okay, the slopes are not equal. Think about what we wrote down on our very first slide. What do you know about slopes with perpendicular lines? They're the opposite reciprocal, and their product is -1, right? Okay, so here's what I would do, is I would find the slopes of these two things. If I'm going from W to O, I would do, well, let's see. I'll go from O to W. So 1 minus -2 over -3 minus -1. Would you have gotten the same thing if you would have started with O? Like if you did -2 minus 1 and -1 minus -3? You would, as long as you go in the same order. Like you can't change in the middle. 1 minus negative 2, that's really 1 plus 2. So that's really a 3. And negative 3 minus negative 1 is really like negative 3 plus 1, which is negative 2. Okay? And then let's do WT. WT would be 1 minus 6 over negative 3 minus 3. 1 minus 6 is negative 5. And negative 3 minus 3 is negative 6. So I could really call that positive 5 over 6. Now at this point, I know you're looking at that and saying, well, they're not opposite reciprocals. Okay, you're right, they're not. But remember, the official definition for perpendicular lines is that they have a product of negative 1. So from here, I would want to show that their product is something other than negative 1. So I would say the product of the slopes is, then I would do 3 over negative 2 times 5 over 6 and show that that would be 15 over negative 12. And then I would say this is not equal to negative 1. Okay, there's your contradiction right there. Okay, that the product is not negative 1, therefore the lines are not perpendicular. So you do have to do a bit of writing for these, but the math should not be difficult. Okay, therefore the lines are not perpendicular. Remember, you can do that little square thing to show that you're done. Remember that.